Okay, I'm going to work through two additional problems for confidence intervals. So the first one says that a travel company wants to estimate the number of miles American families travel when they go on vacation. It tells me from past studies, it is known that the standard deviation is 23.4 miles. Okay, so I'm going to go ahead and kind of jot this down as I read it. So standard deviation is 23.4 miles. And I note in the problem that it tells me that this is coming from past studies and that it is known to be. And so this indicates to me that it is the standard deviation of the population. It is not referring to the 22 families that we have down here. So this is the standard deviation of the population, which is going to be important in just a minute for me to have made that distinction. So you have to decide on the standard deviation if it is referring to the sample that you're talking about in the problem or if it's referring to something else. And because this says that it came from past studies, we know that it's referring to something else. It says in a random sample of 22 families, so I know that my sample size is 22. And it's found that the average number of miles driven is 247, so that's my mean. $247. And it's asking me to find the 95% confidence interval for the population mean. So I know that my z-score for 95% is going to be 1.96. All right, so again, the only trick here is that you need to be sure that you make the right decision on the standard deviation. Because remember, if it's the standard deviation of population, you're going to use a z. If it's the standard deviation of the sample, you'll use a t. And so it's important to make that determination and make it correctly before you start working your problem. Okay, so once we do that, then I'm going to go ahead and just plug in to my formula. Remember that the formula looks like this. Okay, and then it's the same thing on the other side, but it has a plus sign instead. All right, so I'm going to plug my numbers in. My mean is 247, so that'll go first. My z-score is 1.96. My standard deviation is 23.4. And my sample size is 22. And then I'm going to do the same thing on the other side, but I'm going to put a plus sign instead of a minus sign. All right, so now I'm going to plug into my calculator. Remember that you'll plug in the left side and the right side separately. So on the left side, I get 237. I'm going to round it to 2 decimal places, so 237.22. And on the other side, I'm going to get 256.78. All right, so that is my confidence interval. And so now I need to write a sentence to express, just to kind of sum up what it is that we have found. So I'm going to start with my percentage. So I'll start with I am 95% confident, 95% sure. that the average? And remember that in class we have talked about that this is sort of the standard sentence, and then you need to finish it. All right, so average, what are we talking about? We are talking about the number of miles that American families travel. I'm going to abbreviate that just down to number of miles. All right, and then ask yourself for who. Okay, it's not just the 22 families anymore, but it's all families. And we found that to be between, and we'll put our two numbers in. So 237.22 and 256.78. All right, so that's our first problem. Again, the only thing that really should be difficult, if anything, is making that determination on the standard deviation of the population. That's where you want to be careful. Okay, and then after that, you're just plugging your values into your problem. Okay, we're going to look at one more. A random sample of 10 children found that their average growth for the first year was 9.8. So again, I'm going to kind of write as I go. So that's my mean. Assume the variable is normally distributed, just simply means we can use our curve to work the problem. Assume the sample standard deviation. Okay, so they were really nice here in that they told me that we have the sample standard deviation. So that means that I am going to be using a t-value for this problem. Because remember, anytime you have the sample standard deviation, that is a t. All right, and we want to find the 95% confidence interval, and then I'm going back, I forgot the 10. We have a sample of 10, so that's going to be the 10. All right, so I'm going to go ahead and take my second table. We're using the table, this is table F, the t-distribution. I'm going to look at the 95% column, and remember you're going to do one less than your sample size, so if your sample size is 10, you'll go to 9 down the side. So you should be at 2.262 for a t-score. Okay, so again, that is 95% across the top and a DF of 9 down the side. All right, so now I'm just going to plug my numbers into my formula. Remember, you start with your mean. You're going to subtract off your t-score. Multiply by your standard deviation, divided by your sample size. And it's going to be the same calculation on the other side, but it will have a plus sign instead. Okay, we'll go to our calculator. And we'll plug it in. So on the first side, left side, I get 9.11 if I'm rounding to 2 decimal places. And for the other side, I get 10.49. Okay, and again, we would want to write a sentence, and we would start it the same way. I am 95% sure that the average and then ask yourself, what is it that you are doing an average of what? It says average growth. All right, then for who? Not for 10 children, but for all children. That tells me that you understand that you've moved to the population and not just the sample of 10. And then say that that is between and use your two values. All right, so hopefully that helps in understanding just a little bit more. That is one z-score formula and one t-score formula. Again, if you have questions, shoot me an email and ask, and we will try to get those things squared away.